Sound can be thought of as a wave, and the frequency is the number of wave cycles per second, and it's measured in hertz. So here is one wave cycle starting here and ending here, and that is 1 second of time, so that is 1 hertz. The higher the frequency means the higher the pitch. Amplitude is the height of the wave measured in decibels or dB, and it determines the loudness or volume of the sound. Greater amplitude means a louder sound. Let's take a quick, simple look at frequency in relation to its amplitude and pitch. So here I have a very inexpensive app, and it's a tone generator. And right now I just have it randomly set at 450.895 hertz. And this is how I am going to control the frequency, and this is how I'm going to control the volume. Now note, when I bring up the volume, we now see that being measured this way. And also when I change the frequency, I'll go down first. You can see it being measured this way. Let's bring that up a bit. The higher the frequency, the closer these will become. There'll be more cycles per second. I'm going to bring that down a bit, and let's just crank it way up. And that's it. That's just a good way to demonstrate amplitude and frequency. Another way to look at this is I took a recording of similar frequencies and I put it right into an audio track in DaVinci Resolve. But in DaVinci Resolve there is a frequency analyzer. Not that you're going to have to use this, I just want you to know about it, but we're going to play back some of those frequencies and see what they look like in relation to amplitude again here and frequency across the bottom here. Just another way to look at it, another way to help you understand conceptually what they are. So you can see there I was at about 200 hertz, and then I start to change the volume and the pitch. And at about that point I was at 1.6K kilohertz. So that's 1000. K stands for 1000 hertz. And we'll keep going. So again, low frequency, low pitch. A higher frequency is a higher pitch in tone. Now let's take a look at frequency range. This is 10 hertz, 20 hertz, goes all the way up to 20,000 hertz. Remember, K stands for 1000. So these are the very, very high tones that a human being can hear. And we can also hear somewhere down here around 20 hertz. So this is basically the range in which human beings hear. Many of us do not hear up at this end of the scale, and many of us do not hear below 20 hertz, but there are some differences with some individuals. I, in particular, have hearing loss myself here due to age around up in this area here. unless it's very, very loud. And frequency is a spectrum, and it actually keeps going higher and higher and higher until it eventually, believe it or not, becomes color. So the mid-range is usually between 500 and 2000 hertz. Upper bass is 200. If you're ever at a club and you can hear the kick drum, you're in here somewhere. And then if you feel the kick drum in your chest, you're down here somewhere. There's kind of subsonic sound where the air pressure is moving in the room. You can't necessarily hear it, but you can feel it in your chest. Likewise, up at this range, there are some sounds that are well above 20K that we can't hear as humans, but cats and dogs do. Certainly bats are in the supersonic or ultrasound range where they can hear very, very high frequencies that human beings cannot. We're only accessing really a sliver of all frequencies when you look at the big picture. And here's a good way of looking at that. Here we're going from lower frequency to higher frequency again. You can see that demonstrated or illustrated by this waveform. And here we are in the 20 to 20,000 hertz range. We overlap with other species of animals. If you have a cat and you're just sitting there watching your cat one day and one ear just kind of juts off to the left or right, your cat is hearing something that we cannot hear. Dogs can hear a little bit below us and considerably higher than we can. Bats, again, are in the ultrasonic range. They actually can use a radar to detect their prey. Elephants are thought by scientists to be able to send out sub-frequencies, infrasound, through their feet and across the Earth's surface and communicate with other elephants. That is a really kind of a cool thing that they're finding out about sound and animals. Now let's take a look at analog to digital conversion as it relates to sound. In our environment, sound is waves, and we do capture that sound with a microphone, and it turns into an electrical voltage. At this point, it is still an analog signal. But when it goes into a computer, like any other data, it gets converted into a code, a series of ones and zeros. After we source it from the computer, we do churn it back into an electrical voltage. Again, this is an analog signal, and it comes out of a speaker. The sound pressure or waves are reproduced by a physical speaker. So it is now analog again. So you can see this conversion from analog to digital going this way, and then a conversion from the signal being digital and then analog once again. But we're concerned with this binary data here, where the analog signal gets turned into this digital code, and particularly around the concepts of sample rate and bit depth. So bit depth has to do with how accurately is the dynamic range of the audio signal being represented. And the dynamic range is the loudest and softest parts in the audio. The sample rate is how frequently are the frequencies being sampled to recreate in as much fidelity as possible the sound of those frequencies. And for our purposes, we are going to be using 441,000 hertz as our sample rate and 16 bits as our bit depth. Now, these can be both confusing, but here's a really, really simple way of looking at it. The more times you sample the bit depth and the more your sample rate of the frequencies, you can see that it gets higher and higher resolution. Think of this more like pixels in an image or a video. The more times the sample rate is taken and the more times the bit depth is sampled, the higher the resolution or fidelity of sound. And you can see it kind of expressed here. This is low sampling, and this is a little bit better. And it can get really, really good and virtually no error between this and an analog signal. Now, of course, there is this big rush back to analog and LPs and vinyl and hearing things in analog, and it's becoming very, very popular. Some people will argue that the analog sound is more lifelike than a digital sound, and a digital sound is too artificial for them. So I don't know where you land on that. I certainly enjoy both. I like listening to analog music and digital music. There's a Faustian bargain with all technology, and with some good, there's some bad always. But basically, that's what sample rate and bit depth is without leading to too much confusion. Any file that I ask you to export out as a consumable file, in other words, meant for a listener, in audio only, will be in these specifications. And I just want to point out that when we stream music on Spotify, when you listen to your favorite artist, those files are in these specifications. So they are industry standard and they are considered high quality or high fidelity. And there are times when you want to use a higher bit rate in particular. Sometimes you go to 24 bits or 32 bits, which is very, very high quality. It tends to make the file sizes larger and takes up a lot more bandwidth on some of the platforms that we use, especially in podcasting. But there are advantages to having higher bit depths, particularly when you are recording. And there's some more things that you can do. There's more subtle, nuanced things you can do in post-production when you have a higher bit rate. And this is used mostly in music production. So we're going to have a couple of quizzes on this material. One will be in week 5 and then another one, I think, in week 6. And you're going to have this PDF. I'm going to put this up in Canvas so you can use this to help you do those quizzes. I don't want to have people memorize a lot of information. I don't think that's very productive. I just want you to have more of a sense of operational knowledge than anything else, and just a little bit of reinforcement to these concepts. So thanks for watching.